You know what would make this game even cooler? Lights and sounds that react to you hitting the board or making it through the hole. Yeah? How'd you know? We're the same person. You're literally me in a red outfit. We just took 2 takes of this scene with different clothes and cut them together in post. Oh yeah. Can you build it? Yeah. I love playing cornhole. You really can't help but feel happy and stress-free when you're playing a game where you can literally hold a drink in one hand and eat snacks between turns with the other. But what about when night falls? We as people instinctively react to blinking lights, dinging bells, and blaring horns. So first of all, we need to add sound to a lighted cornhole board and make both of them go off when a player scores a point. We'll do this with an Arduino Nano and a few sensors. But let's take it a step further. When a board detects a point being scored, it will play a sound and light up, while also sending a wireless signal to the other board to play a sound as well. Is it necessary? No, it's not. The player's still gonna hear the opposing team's board speaker in the distance, but I don't know anything about wireless communication, and I need to learn at some point for future builds, so I might as well document the struggle for your enjoyment. So I got pretty lucky, because when I spoke about this project to my family, turns out my mom had a cornhole board sitting around. Get some practice in early. It fold out just like that. How do I turn it on? Button. But that's just the ring. And I want more than that. I want lights around this whole thing, all around the edge. I have this battery pack to replace the stock one with so the boards last longer. It holds 8 AA batteries, and at 1.5 volts per battery, I've got 12 volts total to work with. I have this vibration sensor module to detect when a bag hits the board. The actual sensor is this blue cylinder here. It has a spring inside. When the board physically vibrates, so does the spring, which causes it to make contact with an internal wire, completing the circuit and detecting the vibration. These IR LEDs and IR sensors will be used as brake beams, like the ones that prevent garage doors from closing when somebody's standing directly underneath. My garage, on the other hand, has none of those sensors. I'll mount these under the board hole, and when the bag falls through, it will break the beam, thus signaling the player has scored 3 points. For sound, I have this MP3 module, which runs off a micro SD card. I'll pump all that out through this small speaker, and then attach everything to the Arduino along with the LED lights, then activate a particular stored sound effect and flash effect based on sensor information. Finally, I have these RF transceivers that will allow me to send signals between the 2 Arduinos to activate the opposing board's celebration sequence. Keep in mind, I have no idea how to work with any of these sensors. As I said, I've never worked with wireless before. This is all going to be one big experiment. I have no idea how it's going to go. But I'm looking forward to smacking my desk a little bit as I test that vibration sensor. That's going to be fun. Still got to determine what kind of sound I'm going to use as celebration. Maybe it'll be just a horn. Maybe it'll be a police siren and make everybody mad. Maybe a duck honk? That would be hilarious. No, not a duck. A Canada goose. Oh my god, I need to make it a Canada goose honk. Like a really violent goose honk. Nice bell sound or horn to make them think it's just kind of standard sounds, but when it goes through the hole, just a whole flock of geese honking. It's gonna be great. And here we are. I have made this ridiculous circuit. I just uploaded the code to both boards, and I'm kind of concerned that I broke something already. I didn't have a chance to film it, but this LED was on, blinking rapidly, and then it just shut off, so I don't know if something burned up or what. But moving on, let's try the vibration sensor. Who could have seen this coming? You don't test anything with your code, and it doesn't work at all. What a valuable lesson we've learned today. I think I addressed that in my first video. Yeah, that was one of the key points during that speech, wasn't it? Test your code. Test your code. Test your code. Here is my updated circuit. I made this adapter board so it can run completely off of battery power. We'll plug that in. It starts up, add some paper flakes to the speaker so you can see it move, and then you smack the table. Chaos. Or of course break the beam. Pretty cool. But there's a third option if you do the first two in quick succession. Told you I would do it. To demonstrate the wireless functionality, I've hooked up this Arduino Mega with a push button and an LED, same as this Nano you saw, and when I push the button on one, it should blink the LED light on the other. Now that the testing is complete, I wanted to plan out my circuit to make it easier to go from breadboard to permanent circuit board. I'm using a program called Fritzing to do that, which makes it easy to lay out all your hardware components for later reference when you're soldering. Here's my main circuit board, and while it looks a bit messy, the wires are only bent that way to make it easier for me to see where everything connects. On the actual build, they'll be much more compact. Over here, I have a color guide for the wires, so I can tell which ones are meant to be for power, which ones go behind the board, etc, etc. Here I have all my components, and I've copied them over so I can label them with smaller letters for later reference, just as you might do on a printed circuit board. Now, without getting into all the specific wiring details, I want to go over the basics of how my circuit works. I'm using an Arduino Nano as the brains of the circuit, just like I did with my desk automator. It will be taking input from the vibration sensor, as well as the brake beam, which will be connected to the main board via a cable here. When it receives input from either of the sensors, it will talk to this MP3 module, which will then send a signal to this amplifier and out to the speaker to play a sound. To send power to the ring lights that are currently on the boards, as well as the LED strips I'm going to add, I'm using these two MOSFETs here, which will cause the lights to light up at the same time the sound plays. The NRF transceiver will then send a signal to the other board to play a sound as well. Finally, I've added a small voltage regulator to make sure everything gets the correct amount of power, as well as several capacitors, resistors, and a diode to reduce noise to the MP3 module, the amplifier, and the wireless module. I'm going to start by placing the through-hole components because I'm going to need them in place to wire everything up, and it's going to be more difficult to access them once I solder on the headers. Here are the boards with all the passive components in place. I've bent the leads on the backside to hold them there, and I get the feeling I shouldn't have put them all on at once. Cthulhu! The most difficult section by far is going to be this mess here, where all the component leads come together in a maze, sometimes only one hole apart from positive and negative, and I need to be really careful I don't accidentally bridge those with solder, otherwise the circuit's going to be incorrect. If I was to do this again, I would have chosen a larger circuit board so I had more room to place the components farther apart, making my job with soldering a lot easier. Well, I've already bridged the first connection, so I can say this is going great. Here's one of the main boards with all the passive components connected. And the back side, you can see that there are some leads that still have not been soldered. That's because I'm going to be attaching them to wires pushed through the other side, and I don't want to fill in the holes with solder just yet. I've got a few tips for you when you're soldering through-hole components. Wear eye protection. Take breaks along the way. And don't put too much matcha in your morning latte where you can't hold anything steady because you have the jitters. I should really know how sensitive to caffeine I am at this point. I need wires and a cleaver. Don't tell me it's unnecessary. I should probably move those. Man, there's so many different lengths and colors. Where to start? Can I get them all at once without cutting my fingers? Yes! Oh boy. Before I start soldering those, I'm going to add the headers to the board to make it easier to tell where each wire should connect. I'm doing a final layout check to make sure the board matches the diagram, and it does. The only thing I need to change is the headers on the vibration sensor. Currently, they are right-angled headers, so it wants to stand up like that. I'm going to switch them out for straight headers so it can lay down like that, allowing me to reduce the size of the enclosure. Now, the reason you'd want headers at all is because look how many points are being attached to this circuit. Imagine one of these modules goes bad. Headers allows you to easily replace them, where if it's a passive component that goes bad, you only usually need to desolder 2 leads. Headers are finished on the main boards, and I've populated the smaller boards, so now we're ready for wires. Oh boy! Here are the boards with the power and ground wires attached. Got a couple I added to the back side, and it only differed a little bit from the diagram I made. For example, this pink line was originally meant to be a power line on the back side, but I had enough room on the front, and whenever possible it's nice to keep them on one side because then you can tell more easily where everything's routed. Now for the signal wires. And here are the finished boards. You can see what they'll look like with all the modules installed. The only physical difference between the two is this black wire here, which this board doesn't have. In the code, I'm reading a signal on that pin to set the reading and writing pipes of the wireless modules. The writing pipe of one needs to be the reading pipe of the other, and vice versa, so that the two can communicate. Now I just need to remove the leftover flux with some isopropyl alcohol. Just dip a toothbrush in some iso and start scrubbing away. And while I did enjoy making these, I really want to learn how to design printed circuit boards so I can save time on larger manufacturing runs. Keep an eye out for that in a future video. In my previous video where I added trailer lights to my backpack, I went over some tips on how to solder cables. If you'd like those, check out that video. For now, I went ahead and soldered the ones I'm going to need for these cornhole boards. Now all that's left to do before I put everything together is design some enclosures. Off to the computer! CAD, I'm doing CAD, I'm doing CAD, I'm doing CAD, I'm doing CAD. Doing CAD. Doing some CAD. CAD. Hey, what's up? How's it going with that cornhole game? Really good. I soldered up the boards and they didn't work. That doesn't sound good. Yeah, but here's the thing. I made them work with wishful thinking. That's what did it? Well, that and soldering a capacitor across the power and ground leads of the MP3 module, but yeah, wishful thinking. Well, great. Glad to hear it. So what? Looks like you're making a box. Yeah. Is it a well-designed box? Well, it's a box. All right, I'll take it. It's a terribly designed box. Let's add some inserts to this piece of garbage. I made a simple insert sizer to check the fit of various diameters and depths. Thankfully got on the second try because these things aren't cheap. And I have a set of tips for my soldering iron specifically meant for adding in inserts to make the job easier. The one issue with printing everything in glossy black is it doesn't show up well on camera. But we're going to try anyway. All the inserts have been added. Here's the box for the main board, as well as the lid which will hold the speaker. And here's the box for the brake beam LED, which shifted a bit due to some crashes during printing. But that's okay. No one's going to see it underneath the cornhole board. Want to be sure I don't misplug anything in and blow something up. We've got all the power ports, a small hole for the IR receiver with a similar one on the smaller box for the IR LED, a larger hole so that I can access the SD card in the MP3 player, and a similar hole so that I can insert a USB cable and update the Arduino as needed. For those, I just have a couple push-in plugs, and on the top, I added a grate so you can more easily hear the sound. Now that the circuits are all packaged up, it's time to add some lights to the cornhole boards. Normally, you could just add the lights around the board, but as you saw earlier, mine are hinged, and that means that when I put them away, they're going to bend, and they would damage the lights. So I need to cut the lights and add some stranded wires across so they can kind of flex as I fold them up. So I'm first going to drill a hole through the aluminum so I can route the lights inside. Who needs structural integrity anyway? Probably should have used a pilot hole. Round 2. Oh gosh. Well, it made it. Kind of rough around the edges. Do this properly and file it. So many shavings. Ah, well, there you go. I drilled it on this side. Now it's easier to see. Give this a quick wipe down to make sure the adhesive sticks as well as it can. I always question how well this peel and stick stuff is going to work, but we'll give it a go. Ah! Now I just got to cut these very carefully Alright, fine. I won't have my fun. Easier said than done getting this off without cutting the traces. So we'll have the battery pack and main circuit board sitting here. Power will go out through the cable, wrap around with the LED strip, go in through the side, through the hinge, back out, wrap around once again, do another in and out over this latch that holds the boards closed, and the LED strips then finish about here. And then I also have a couple grommets that I 3D printed to make sure the wires hold up through repeated use. I originally planned on gluing these, but let's see how I did with press fit tolerance. Oh yeah! But I still need to glue the ones on the hinge because those don't have end caps. Oh, that is satisfying. There we go. Now it's time to add some wires. Oh no! Watch your fingers. Now let's see how I did. Turn off the light, the other light, the other light. Take this pack, plug it in. Where's the switch? Ta-da! To provide some strain relief, I'm going to fill the ends of the grommets with hot glue. I'm also using some to protect the connections from weather. It's not the greatest looking, but if anyone's playing on my lighted cornhole board and commenting on the wiring, I'll just tell them to leave. Of course, I didn't glue the hinge grommets, and you can see it's working as intended. And there you have it. 2 easily portable, foldable, lighted cornhole boards. Now let's play Wizard of Oz and give them a brain and a voice. I had a bit of an oversight when I designed the enclosure and the main circuit board layout. I didn't account for the movement of this bar as it collapses for storage. The issue is the IR receiver is directly in the center of the enclosure, and it was supposed to match up with the center line of the hole for maximum effectiveness. That can't happen because I need clearance here, so I just drilled a hole inside of the enclosure, and I'm going to take the main circuit board, desolder the IR receiver, and move it over a bit to match. Also making an appearance for my backpack video is 3M Dual Lock. Clean off everything. After attaching the boxes, I realized I wanted them a little bit away from the ring, so I moved them back. I added the battery pack, test fit all the cables, and I added these 2 wooden blocks so that when I put the legs down, they don't knock into the cables or the battery pack. And as a final perfect display of cable management, I'm going to add some hot glue to hold them down. Or rather, up. It's time to play some cornhole! After quite a bit of playtesting, you should know these are far from perfect. I still have issues with sounds and lights activating when they shouldn't, as well as not activating when they should. They're good enough for a day at the park though, and as I improve the code on these things, I'll be one of the few people on this earth who can say, hang on, I need to go update my cornhole boards. Well, I had a bit of a break from the rain, but I want to try playing cornhole indoors anyway. There you are, perfect timing, get over here. They're ready? They are. It was just one modification left. I actually had to solder on another capacitor, this time in line with the speaker. But now it works. All right, let's do this. Check it out. Hit the switch under that one and we'll get started. Hey, that's pretty cool. Hey, don't gloat. What? Never mind. Wow, you actually pulled it off. They're done. Yeah. Told you I could build it. I gotta say, I'm impressed. I didn't know that you or we could do this. Yeah, well, you know what they say. Life's full of surprises. It sure is. What was that? To my new viewers, welcome. And to my returning viewers and subscribers, thank you for bearing with me as I made this video. I severely underestimated how long the learning process would take, yet I felt the results were worth it in the end. I hope you did as well. In total, I put over 180 hours into this video, while my previous 4 took a third of that max. I bring this up because growth is a great thing, but so is having realistic expectations of how you might progress. While I'm not yet releasing videos as often as I would like, I want to make sure I can keep this up for you in the long term. Somewhere in there I'll strike a balance, and make sure you give yourself the same courtesy with your own projects. Now a bit on grit. During this build, I often couldn't get things to work. Communication interfaces, Arduino interrupts, and electrical noise all threw me for a loop. At times I considered dropping the project, as a younger me occasionally would have done, but that would have been a mistake. I allowed myself to feel frustrated and took breaks as needed. Nearly every time, I would make progress the next day, having cleared my head with some rest. I'm working on moving my habits towards the grittier side, and if you're someone who struggles with seeing things through and would like to do the same, I highly recommend reading Grit by Angela Duckworth. It's given me a newfound appreciation for conquering challenges. Finally, in the interest of time, I couldn't include every build detail in this video, particularly explanations of the code and implementing each module. So please, if you have any questions about how my boards work, or are looking for some learning resources for replicating my results, let me know in the comments. I'd love to share something that could help you with your own build. Please consider subscribing for more projects, and most importantly, thank you for watching. Come on. I wonder if you can hear these flies on the mic, because they are really bugging me. Alright, that was bad. I don't know what my lines are. I keep holding up this paper, and... Ugh. Man, Cthulhu, you seem really tense. Could really use a spa day. Creaking like a Halloween cartoon skeleton. To the computer! Oh, missed the doorknob. Trailer lights to my backpack. I want... Card came out. Last time it was leaf blowers, now it's garbage trucks. Whenever I start filming for the day. I mean, obviously I'm happy for what they do, but it's just so perfectly timed. I think there's like a dispatcher who's like, "We see him filming! Go!" Cut the lights and solder on some stranded my cable here on this side. And hello, light. Closing latch. And final end over here. No, it was magic. I'm definitely not setting up that shot you saw at the end. Oh. Oops.